what I did first hour?
No.
First hour class?
You had a meeting.
Wait 10 minutes? Oh yeah, I just bailed on him. I just said, I am not coming to first hour class. Oops, sorry.
Oh.
No, it's still there. Wow. So, this actually might be important because first hour might be trying to watch the video. So, because I was not there. Second hour, we're good. Seventh hour will be fine. So, let's see who we be missing. We be missing uno, dos. That's it. Got it. Okay. Bless you. All right. So, not usually, more often than not, when one class gets shortchanged, it's you guys. But today, it's actually the other way around. This first hour, I wasn't there at all. Second hour, I was pretty frazzled by the time I got there. This is the only class that I was going to say normal, but we all know I'm never normal, so as normal as I can be for. So, let's get started. Homework, go.
You do number 13.
Not right now. I heard something about 13. Is that what I heard? I saw Brooklyn today. She was in ACLAB. So she's abandoning math class to take a bio test? That's kind of weird. Great. I heard 13. Is that what I heard?
Wednesday.
I'm going to guess that you know Z. Okay. What is Z? 3. Z is 3. So really, we're doing x plus y has to be -5, and x minus y has to be -1. People who ask the question, are we okay with that? Well, not all of you asked the question. I don't know. I don't remember who asked the question. So whoever asked the question, are you okay with? Let me rephrase. Is there anybody that's not okay that doesn't know where that came from? It's okay if you don't know. Just tell me, and then I'll explain. Yep. Okay.
3 and 9 that are in the brackets.
Okay. So we are saying that we have two matrices that are the same. So we're saying x plus y and 3 and x minus y and 9. They're saying that that's the same as -5 and z and -1 and 9. So for these two matrices to be the same, then each element, that's what I wanted, needs to be the same. So 9 is the same as 9, so we're good there. So 3 has to be z. And then x plus y has to be -5 and x minus y has to be -1. Good? Yes, sir.
So when there's not 3 columns, it's not the twos, or it's not the first one, the second element.
Well, there are only 4 elements in this. This is 1, this is 1, this is 1, and this is 1. Is that what you were getting at or not?
I mean, like when there's the 3 columns,
Mhm.
it's like the first element versus that.
No, it is impossible for a 2 by 2 to be equal to a 2 by 3. Still not what you're asking. Basically, for two matrices to be equal, they have to be the same dimensions, and each corresponding spot has to be exactly the same as the other one. So, I'm not sure what you're getting at if I haven't gotten into it yet. Are you're okay? All right.
I think he's saying like if there's 3 columns and then 3 rows, right? And you're saying like 2 of them. Oh, then yeah, I know what you're saying.
What'd I do? An augmented matrix. Gotcha. Yeah, that's coming from equations, so that doesn't really apply to this stuff, which is still not helpful, but I'm gonna move on. Is that okay?
Yeah.
Okay. So we have to solve this what? System of equations. Do we know how to solve a system of equations? We're gonna get really good when we get back to chapter 9, but for right now, what could we do? Hello. Okay, somebody want to work on that?
I got you.
Alright guys. Alright, so you guys want to do elimination? Alright, bet. Wait, y'all know what that is, right?
Yes.
I just saw some pieces. Let me know if I mess up.
You'll find.
Oh, Cheryl, you want to come up
You
here?
could have just left.
Huh? I know, I could have just left it, but I like the X's. I make sure. Boom, we good? We good? Yeah, I flipped it, I just noticed that. Oh, okay. So y equals -2, we good with that? Does anyone need to know where we got that from? Jalen? Alright, bro. So, we take the y equals -2, we put it back into the equation. And then bam. So that means x is equal to -3. Alright, Jake, you have a question? What's the question, Jake?
Where does y equal
So when we do elimination, we get it to where we only have one variable term left, so y, 1y plus 1y equals 2y.
Oh, wait, never mind. I see it.
Alright, cool. Jalen, any more questions? Alright, just making sure. Alright, so, are we good? Anyone need to take a photo? Yeah, there probably was. I just noticed it, but. Yeah, you're right. I mean, but you need a calculator to do that. Any more questions on the homework? Karma, you got a question?
No, no, I don't. I
Here you
figured 13 and 15 like this.
Okay. Any other questions? All right. So the notes.
Okay, so it's all done, so, okay, I'm done for the day then?
Yeah.
So I typically do
Both dollars?
Dang.
All right, any others? Or did we finish?
I finished the research.
Okay, let's go.
Wait, grab one.
Okay, so we have another system of equations, yes? All right, and we're gonna get to that in a minute, but I just wanted to throw that up on the board for now. As we get rolling for today, I would like you to spend a minute and multiply these two matrices together. If you can. If you can multiply those two matrices together, please do that. I don't know what that one is.
I think it's a nurse pass, my bad.
No. There are a couple up there.
Okay.
What is back there? So remember row times column, correct? So first row times first column. Are we, by the way, are we allowed to multiply these matrices?
Yes.
Why? 2 by 2, 2 by 1, so we're good.
Yes.
So if we multiply these two matrices together, what would be, so the answer is going to be a 2 by 1. So we're only going to have two elements, a top and a bottom. So what would the top element be? Plus 5y. Huh.
Oh.
Okay.
Sounds familiar. What would the bottom element be? 2x minus. Wow. So when we multiply this matrix times this matrix, we basically get the left-hand side of the system. So why don't we just say that that's equal to right-hand side of the system? Is that logical?
Yeah.
What we have just done is we have written what we call a matrix equation. God bless you. So what we're coming up with is another way, believe it or not, to solve a system of equations. We're also going to do a few things in the meantime that will kind of enlighten us in some other directions. But this is a matrix equation. So with the augmented matrix that we did yesterday, we kind of took a system of equations and just wrote it different and just wrote the numbers on them, the coefficients and the constants, God bless you, and things like that. This matrix equation is actually the system, right? Because this times this gives us the left side, and then the right side is just the constants. So we're going to keep dropping in on this problem as we go through the day. Okay, so kind of keep this around, keep it there. We'll come back to it. Okay? All right. Here's my next question. If we had is that easy to solve? No?
Yes.
X equals 4, y equals -6, right? We would love stuff like this, wouldn't we? So, if at some point we could take this system of equations, this matrix equation, if we could take this matrix equation and turn it into this, that'd be awesome, right? So that's our goal. That is our goal. Next question. Can you multiply these two matrices for me? Multiply those two, please.
I was finishing my test, but I didn't want to go on it.
I'm sorry.
I want to learn how to. What do you say? Say yes.
Okay, done? What'd you get? Not plus. Because remember, this is a 2 by 2, this is a 2 by 1, so our answer is going to be a 2 by 1. Yes? And the top element, the 2 by 1, is x, and the bottom one is that's interesting. So we multiplied that matrix by xy, and we got xy. So in effect, this matrix is kind of the same as 1, right? Because we multiply something by this matrix and we get the original. It's kind of like 1. Because this happens, and it doesn't matter what's here, we're always going to get whatever's here will be here. And it could be a 2x2, a 2x3, a 2x4, it could be anything. This matrix has very special properties, and because of it, we call it the identity matrix. The identity matrix is a matrix that you multiply something by, and you get what you started with, which is very similar to the number 1. Okay? Which is why 1 is called the identity element of multiplication. Because if you multiply by 1, you get what you started with. So what do you think is the identity element of addition? 0 is correct. Because you add 0 to anything and you get what you started with. So it's all identity stuff. Okay? So the identity matrix is right here. Now what happens if we're not multiplying a 2 by 1, but maybe we're multiplying a 3 by 1? Well, we would need a bigger identity matrix. Here's the deal with an identity matrix. A, there's more than one identity matrix. There are tons and tons of different identity matrices. Number 2, an identity matrix must be square. Can't have a 2 by 4 identity matrix. Makes no sense. 3, an identity matrix is formed by having 1s in the diagonal from top left to bottom right. So maybe 1, 1, 1. And every other element is a 0. 0, 0, 0, 0, 0, 0. So this would be a 3 by 3 identity matrix. You can make identity matrices whatever size you want. As long as that size is square. You got it. Okay. Questions there? Cool. Back to this guy. I'd love to get rid of this, wouldn't you? If these weren't matrices and were just numbers and variables and stuff like that, but it were an equation, what would we do to get rid of something like that? We divide by it, right? Because it's being multiplied. So we'd get rid of it by dividing. There's only one problem. Can't divide matrices. So that's a problem. So maybe there's a solution. Close. Very close. We just use another word. What would you do to solve that equation? Divide by 4. But if I said you can't divide by 4, multiply by 1/4. 1/4 is called the multiplicative inverse. And that's what we want to do here. We want to come up with what we call an inverse matrix. And that's going to help us to get rid of this thing. We divided by 4 because we were multiplying by 4. We want to find the inverse of this matrix so that we can get rid of it. Okay? So, the obvious question is, how do we find an inverse matrix? So what we're going to do is, in this case, we'll call that matrix A. So matrix A is 3, 5, 2, -4. Okay? Actually, I got to do something else first before I get back to that. We're going to start with a very generic matrix. We'll call it A, B, C, D. Okay? So matrix A in this case is A, B, C, D. Make it nice and general so that you can see what we're doing. The inverse matrix, which will always be denoted as A to the -1st, that doesn't mean to the -1st, it means inverse, is going to have 2 parts to it. The first part is a numerical part, the second part is a matrix part. The numerical part is this. It's going to be 1 over, and this is something we're going to learn more tomorrow, it's called the determinant. But it's AD minus CB. So in other words, it's this diagonal minus this diagonal. The diagonal going down from the left minus the diagonal going up from the left. Okay there? So that's the numerical part, because AD minus CB will be a number, and we'll just do the reciprocal of that number. Then there is a matrix part. And the matrix part, we're just going to adjust what we have here. And we have to make these specific moves. We're going to flip-flop A and D. So the D is going to go there and the A is going to go there. And then we're going to change the signs of B and C. So flip-flop A and D, change the signs of B and C. So negative B, negative C. And this is how we get the inverse matrix. Now it seems like a lot, it seems kind of bizarre, but there is a reason for it. Maybe we'll discuss that reason now. So, let's find the inverse of matrix A. Let's find the inverse of matrix A. Step 1. Determinant. 1 over negative 12 minus 10, which gives us negative 22. So that is the numerical part of it. Now we do the matrix part of it. Flip-flop A and D, so negative 4 goes here and 3 goes down there. And change the signs of the other two. Leave them in the same spot, just change their sign. So negative 5 and negative 2. This is the inverse matrix. Now, if we're going to use this matrix, which we're going to do in a minute, we probably just want to leave it the way it is. But if the entire question says, find the inverse matrix, then I would treat 1 over negative 22 as a scalar. Very good. I would treat this as a scalar, and I would multiply it. I would distribute it. And so if the question is, what is the inverse matrix, your answer should probably be negative 4 times 1 over negative 22 would be positive 4 over 22, which can be reduced to 2 over 11. This one would be 5 over 22. This one would be positive 1 over 11. And this would be negative 3 over 22. So like I said, if the entire question is find the inverse matrix, there's your answer. But back to our problem. If we are going to use that, which we're about to, then I would strongly suggest leaving it like that. Okay, leave that scalar on the outside. Because what we're going to end up doing is we're going to multiply it by it, and I would rather multiply that than multiply that. Reasonable? So, the next thing I would like you to do. You said that what we would love to do is to divide by this. But you also said that since we can't divide, we could multiply by the, you used the word reciprocal over here, which we kind of changed to the inverse. Multiply by the inverse. So, it's the multiplicative inverse. When we're dealing with numbers, like here, would be the multiplicative inverse. By the way, what would we be multiplying by in this case? 1/4. What is the relationship between 1/4 and 4? It's the multiplicative inverse, but it's also the reciprocal, because multiplicative inverse means the exact same thing as reciprocal. So if you ever hear the phrase multiplicative inverse, they actually mean reciprocal. Additive inverse, what do you think that means? What-
If you're adding 4, you got negative reciprocal.
No, don't say. I heard people saying change the sign. I heard people say it's the negative. What's another word for that? Opposite. Additive inverse is exactly the same as opposite, and multiplicative inverse is exactly the same as reciprocal. Yep. Anyway, back to our problem. I'm not going to have time. Oh, wait. You have to make it up? Because I have the meeting afterwards, and I can. Yeah, can we start in a couple minutes? Actually, come on. Okay, just grab a seat for about a minute. Okay, let me get to a certain spot. So here we are. We want to get rid of this, so we want to do it by multiplying by the inverse, which is this thing right here. So we're going to multiply by that. So here we go. Negative 1 over 22 times negative 4, negative 5, negative 2, 3. So, you know what I'm going to ask you to do next? Multiply. Can you do me a favor? Can you multiply? Let's save this. Let's save the scalar, and let's just multiply the two matrices together. Multiply the 2 by 2 times the 2 by 2. Okay? All right, get to work on that. No, not calculator time. Doesn't do you any good. I don't want you to. I want you to get a little bit of practice. I want you to spend 1 minute multiplying those out and everything like that. Good? So what's your trustworthiness on a scale of 1 to 10? After class is over, I'm going to go to
That makes sense.
I have to leave it out 20 minutes. But there should be a problem. I'm fine with it. Which one
Oh, maybe you do this. I thought it was
This? Yeah, it's kind of nice. Okay, sorry. Talk to me about what you're doing. I like that one, by the way. So talk to me about this one. Okay, so go. You stayed there. That's what you did. Most of the time, when you're making mistakes on this multiplication, it's because you're not moving. Okay? Remember. We talked about this yesterday, and this is why. Okay? This is why I want you working on this. First element of the row times first element of the column. Second element of the row, second element of the column. Speak it out, talk it out to make sure that you are doing this. Yes,
Negative 22 for the top.
There we go.
And then
That's so confused.
okay, so walk me through it. Where are you?
I don't know. I wasn't
You're here.
on this part yesterday.
Okay, no, that's okay. Uh-huh. Okay, good. No, not -4. Remember, first element of the row, first element of the column. Second element of the row, second element of the column.
Oh.
So you actually have that here. -12 minus, oh, so you got -22. That's good. Talk to me about this one. No? Which one are we doing? Which of these are we doing? Just point to one. I don't care which one you do. Okay, that one. Okay, I had pointed to that one. So okay,
Oh,
so
you
that
did?
one.
Oh, okay.
No, that's fine. So we're doing that one. Okay. So tell me again.
Oh, no, you're supposed to add it.
No.
No.
Because it's still in the first column. So you're going to do second row, first column. So negative. So yeah. Okay. So this is row 2, column 1. So we need to do row 2, column 1. So first element of the row times first element of the column gives you. Okay. And then second element of the row times second element of the column. Which is?
0.
You got it. Okay, it is so easy to make little dinky mistakes here, which is what I was saying yesterday, which is why you just have to keep doing these. So don't use the calculator and actually do it by hand, because remember on I got a lot to do still. What am I going to do on a test to guarantee that you have to do it by hand? I'll just put one variable in there. All I have to do is put one variable in there and it throws everything for a loop. Well, we're going to get to that. Okay, so, all right, I got to jump ahead because I don't have a lot of time. But what should you get when you multiply these two matrices together? And then we still have that scalar on the outside, right? Now, so this times this gave us this. We also still have the xy here, correct? What happens when we multiply the scalar now? We distribute the scalar, and what does that give us? 1, 0, 0. So we got the identity matrix. Now, does it make sense? I squeaked. Puberty's a wonderful thing, isn't it?
On this one.
I squeaked. Not on purpose. Okay, please. Thank you. Does it make sense that we got the identity matrix? Why? Because we're multiplying a matrix times its inverse. If you multiply a number times its multiplicative inverse, what do you get? You get 1. If you multiply a matrix times its inverse, what should you get? 1, which is the identity matrix. Now, what is this times this? Just xy. So what happened? Okay, we had this big, ugly, fairly nasty mess over here. And the reality is when we multiply it all out, what do we get? Just the xy. Now, understand this. Okay? I want you to understand how it works because think about this. When we do this problem and we divide by 4, do we spend a lot of time saying, okay, so I'm going to divide by 4. So 4 divided by 4 is 1, and 1 times x is x. Do we spend a lot of time doing that? No, we just go, they cancel out, which is really what's going on right here. So the reality is when you're doing these problems, you don't have to multiply all this out, because if you've gotten the inverse correctly, you know what it's going to be, right? You know you're going to get that. Now, what do you, well, you can use it to check, that is fine. But what do you have to do? We have to multiply it on the other side because as you know, what we do to one side, we have to do to the other side. So, don't write this down. For the next 30 seconds, don't write down what I'm writing. Okay? So, what we're saying then is that we multiply it over here also. We'll put the negative 1 over 22 on the outside somewhere. We'll do negative 4, negative 5, negative 2, 3. And then over here, we have negative 1 over 22. So, we multiply this, right? Okay, so go ahead, get started. Tell me what, huh? Say it again. We can't multiply these? We can't multiply these because this is a 2 by 1 and this is a 2 by 2. So we can't do it that way. But, well, of course we can do it. We got to be able to solve this, don't we? So, and that's why I said don't write it down. But now you can start to write again. Because where did we multiply the inverse here?
On the left side.
On the left side. Can we multiply the inverse on the left side here?
Yes.
In fact, that's doing the same thing to both sides, isn't it? If we multiply it on the left here, we want to multiply it on the left here. We always want to multiply it on the left here. So I'm going to actually move this over a little bit and put the 410 here. And then before it, I'm still going to keep the scalar out in front because I don't want to multiply with the scalar. That's a pain until the very end. Negative 4, negative 5, negative 2, 3. So now we're multiplying a 2 by 2 times a 2 by 1, and now we're good to go. So go ahead. Multiply the 2 by 2 times the 2 by 1. It should not take as long because... No, this one you're actually getting something out of. Well, what you're going to get out of this is the answer. Oh, don't use the calculator. Come on, I'm trying to get you. I don't want you to mess up. I don't want you to mess up on tests. I want you to get practice here. This shouldn't take long, which is good because we don't have long anyway.
Okay,
I always say you lost, but I always know where you are. Can you multiply this 2 by 2 times this 2 by 1?
yeah.
First row, first column. Go.
Okay.
Remember, talk yourself through it. First element of the row times first element of the column. Second element of the row times second element of the column. Here's what I see because I have a minute, okay? I'm seeing first element times first element is negative 16, God bless you, negative 16. Second element times second element is negative 50. Negative 16 and negative 50 is negative 66. Then we do it for the bottom. First element of the row, first element of the column is negative 8. Second element of the row, second element of the column is 30. Negative 8 and 30 is 22. Remember that the scalar is still there. So now we distribute the scalar. then we get positive 3, negative 1. So guess what? We have our solution. What is the ordered pair? 3, negative 1, and that is our answer to the system of equations. And you certainly can use that, you can take that and plug it in to check it. 3 times 3 is 9, 5 times negative 1 is negative 5, 9 minus 5 is 4, 2 times 3 is 6, minus 4 times negative 1 is negative 4, 6 minus negative 4 is 10. At the buzzer, he got it done. Have a wonderful day, ladies and gentlemen. See you tomorrow.